All right, in this lesson, we're going to look at graphing functions using vertical and horizontal shifts. We're going to look at vertical shifts first. So let's look at this function here. And so this function is actually f of x equal the square root of x. So that's what this function represents. Okay, so if when we talk about vertical shifts, so if overlapping this function with the green graph here, so when we talk about vertical shifts, that basically means we're going up, we're going to shift vertically up, or we're going to shift vertically down. What I want you to notice though, as we shift vertically up or down, notice that the x-coordinate stays the same. All right, so notice that in this point right here, you'll see that that's 1, 1. So when I go up, the x-coordinate still stays 1. It's the y-coordinate that changes, right? So this is now 1, 2. This is now 1, 3. This is now 1, 4, 1, 5, and so on. All right, so when I go down, so let's use this point here where we have 4, 2. So when I shift vertically down, notice that the x-coordinate stays the same. It's the y-coordinate that changes. So when I go down, let's say 1 unit, so this is now 4. Notice the x-coordinate stayed the same. The y-coordinate decreased by 1. So we went from y-coordinate of 2 to a y-coordinate of 1. If I go down here, from here to here, okay, notice I went down 1, 2, 3, 4. So I went down 4 units. The x-coordinate stayed the same. The y-coordinate changed. So when we talk about vertical shifts, it's the y-coordinate that changes. Okay, so it's the y-coordinate that changes. The x-coordinate stays the same. The y-coordinate changes. Okay, now what that means is this. So if I want to look at, let's say I want to graph g of x, which is f of x plus 2. Okay, so g of x, which is f of x plus 2. So this function f of x, remember that's a square root function, so that means that, oh, I remember I'm overlapping this. All right, so that means that I'm going to take this function right here, f of x, which is this, and I'm going to shift it up 2 units because this says to each y-coordinate I'm going to add 2 units. So I'm going to shift it up 2. So 1, oops, let me do it again. So 1, now notice my shifting. I'm going up 1 and then up another one. So that's up 2 units. So notice that each of those y-coordinates have been shifted up 2 units. That's important to see that. All right, so if I call this function g of x here and I graph it, I'm going to go ahead and use this color. So I'm going to shift this up 2 units. I'm going to shift this point up 2 units, this y-coordinate, this point up 2 units. I'm going to shift this point up 2 units. And I'm using those points because those are nice points. 0, 0, 1, 1, 4, 2. Okay? And so I get this. And so this is the function g of x, which equals f of x plus 2, which is really, in this case, the square root of x plus 2. Okay? All right. Now, if I talk about shifting it down 2 units, so let's say I want to graph the function h of x, which is f of x minus 2. So remember, this function here is f of x. I want to graph h of x. So remember what that means. So positive 2. So if you have your function and then plus 2, so you're going to shift it up 2. So you notice that plus 2 moves it up 2. Minus 2, then, by the same idea, you're going to shift it down 2. So every point on that graph, you're going to shift down 2 units. 1, 2, 1, 2, 1, 2, and so on. All right? And so when I do that, let's see, I'm going to get 1, 2, and it'll look something like this, right? All right, so notice f of x, to graph g of x, I move it up 2. To graph h of x, f of x minus 2, I move it down 2. All right, so the vertical shift up and down, that's the easiest to understand. That's the easiest to understand. So let me go ahead and draw this graph, and I'm going to go ahead and use this pin here. So we have 0, 0. Move this down 2 units, so 1, 2, and then 1, 2. So I get something that looks like this. All right, and so this is h of x, which equals f of x minus 2. All right, so let's talk about in general what this means. All right, so from what we just talked about, we now know this. And remember, the vertical shifts are the easiest. So given a function f of x, a new function g of x, which is f of x plus k, which is what we have here, f of x minus 2, f of x plus 2. Where g of x is f of x plus k, where k is a constant, is a vertical shift. So if you have a constant outside that function, that's going to be a vertical shift of the function f of x. So all the outputs, so remember we talked about output. Output is that y value. So notice that when I shift it up or down, it is the y value that changes, right? So the output. All right, so the x values are called the inputs. So notice the x coordinates stayed the same. It was the y value that changed each time. Okay, so that's important to understand. So all of the output values change by k units. If k is positive, we move up. If k is negative, we move down. Okay, so that's the easiest kind. Up, down, vertical shift. It's important to visualize this, that as you go up and down, the x coordinates stay the same. It is the y values that changed. Okay? All right, so that is vertical shift. Now let's talk about horizontal shifts. Horizontal shifts. Okay, so we're going to talk about horizontal shifts. And to do that, let's look at this function to talk about the idea of horizontal shifts. So we have this function here. And just to let you know, this is the function f of x equal x squared. Okay? So this is a function f of x equal x squared. And I want you to notice when we talked about horizontal shifts, just like when we talked about vertical shifts earlier, when I shift horizontally to the right or when I shift horizontally to the left, okay, that's a horizontal shift. I want you to notice something. Okay, so you see when I go from left to right or left to right like this, when I go left to right, let's look at what changes, the x or the y coordinate. So notice when I go from left to right, see this point right here, focus on this point right here, 1, 1. Focus on that point, 1, 1. When I go from left to right, this point right here, the y value is still the same. What changed? What changed was the x coordinate, right? So as I go from left to right, the y value stays the same. The y value stays the same. It is the x coordinates that's changing. When we went up and down, the x coordinates stayed the same. It was the y coordinate that changed. So when we go from left to right, it is the x coordinate that changes. So the x coordinate changes, right? The x coordinate changes. So if you focus at the origin right here, the vertex of this parabola, if you focus on the vertex of this parabola, this is 0, 0. Notice this is now 1, 0. So the y values stay the same. 2, 0. The y value 0 stayed the same. So the x changed each time. Okay, so what does that mean in terms of the notation? That's important to see. All right, so I'm going to write this notation down, and then we're going to discuss it. Okay, so the notation you're going to see will be something like this. So remember, this is our parent function, x squared, and notice that I am from this input x, I'm subtracting 2. All right, so that's going to be that idea of where the x coordinate changes. All right, so the x coordinate is changing. I'm subtracting 2, or adding 2, or whatever the value may be. Okay, so notice the notation. Notice that the number is inside the squaring function. It's inside what's being squared, not on the outside. Okay, it's not on the outside here. If it was on the outside, then it would be a vertical shift. So if you see it on the inside of that parent function, then it will be a horizontal shift. But let's think about what this is doing right here. So this says I'm going to take each of those inputs from my function x squared, from this quadratic function, and I'm going to decrease it by 2. So I want to just focus on this one here. Let's look at this one right here. So when x is 0 and I subtract 2, which is what this is saying, I'm going to get a new x coordinate, -2, right? And so when I do that, and I substitute that in here, I get negative 2 minus 2 squared, which is the negative 4 squared, which is 16. All right, so I'm going to get that y value, 16. If I take x is 1 and I subtract 2 from it, so 1 subtract 2 and I square it, I'm going to get 1, let's see, 1 subtract 2, I'm sorry, 1 subtract 2, I'll get 1 squared, which is 1. Let me make sure I'm doing this. All right, so let's do this again. 1 subtract 2 is negative 1. I put a 1 here. I apologize for that. That's a negative 1. A negative 1 and a negative 2 is a negative 3, and a negative 3 squared is 9, so I get 9. 2 subtract 2 is 0. Okay, and so 0 minus 2 squared is a negative 2 squared, which is 4. And then 3 subtract 2, 3 subtract 2 is going to be the x value of what? That's going to be 1. And so now put that new x value in here. So 1 subtract 2 squared will be negative 1 squared, which is 1. And then if this is 4, 4 squared is 16. So 4 subtract, remember you're decreasing it by 2. So 4 subtract 2 is 2. And then when I substitute 2 into here, I get 2 minus 2 squared is 0 squared, which is 0. And then keep on going. I want you to notice something. When x is 5, that should be 0 here. When x is 5 and I subtract 2, I get a new x-coordinate of 3. And so when I substitute 3 into here, I get 3 minus 2 squared, which is 1 squared, which is 1. And let's see, that was 25. And then when x is 6, 6 squared is 36. And if I take this and subtract 2 from it, I get 4. And when I put 4 in here, I get 4 minus 2 squared, which is 2 squared, which is 4. Let's do one more. And you'll see where I'm going with this. 4 minus 2 squared is 4. When x is, let's say, 7 squared is 49. 7 subtract 2 is 5. And then I substitute 5 in here. 5 minus 2 squared is 3 squared, which is 9. Okay. Now, here's what I want you to notice. Now, I know this looks convoluted right now, but here's what I want you to notice. So remember when we talked about shifting horizontally, going left, right, we talked about the fact that when I shift horizontally, the y coordinates will stay the same. It's the x coordinates that change, right? So the y coordinates stay the same. It was the x coordinates that change. So what I want you to notice is, you see this 0, 1, 4 right here, 0, 1, 4, 9. I want you to focus on that. And then I'm going to find 0, 1, 4, 9. Remember, the y coordinates stay the same. I'm going to find 0, 1, 4, 9 here. And then I want you to compare the x coordinates. So notice that this x coordinate to go to this x coordinate, see the y values stay the same, right? 0, 1, 4, 9. So I want you to notice what happened to the x coordinates, the corresponding x coordinates. 0 plus 2, right, is 2. 1, so let me do it this way. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. So what's happening is this. So if you look at this graph right here, what's happening is that when I graph this, the function f of x equal x squared, which is what you see here, is actually being shifted 2 units plus 2 units to the right. 2 units to the right. So when I graph this right here, using that t-table that we just found, when I graph that, in reality what's happening is that I'm being shifted 2 units to the right. What confuses students is they see a negative 2 and they think, when they see that negative 2, they think, oh, I got to shift to the left because it's negative. That's not true. Intuitively, you got to think differently. It doesn't make sense intuitively when you look at it. But when you look at this, to get those y values to be the same, 0, 1, 4, 9, 0, 1, 4, 9, and you look at the x-coordinates, remember the x-coordinate changes, each time I went from 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So you're actually shifting it to the right. So I want to show you that this is true. So if I take those coordinates here and put it on this graph, so let's do negative 1, 9. So negative 1, 9 is right here. I'm going to do it in this color right here. Okay? And the next one is, let's do 0, 4. 0, 4 is right here. 1, 1. Let's say 0, 4. All right, so 0, 4 is here. So 0, 4 is right here. 1, 1 is right here. 2, 0 is right here. 3, 1 is right here. Oops. 4, 4 is right here. And then 5, 9 is right here. All right, so let's check it again. Negative 1, 9. Negative 1, 9. Oops, I put 1, 9. Negative 1, 9 is right here. All right, so let's fix that. So that should not be here. Okay, so I want you to notice what's happening. So look at those little dots here, except this one right here. I did make a mistake here. Okay, so notice I'm gonna connect those dots here. So notice that when I connect the dots, see what happens? I went 2 units to the right. So I'm gonna go from here to here. All right. So the effect, and that's important to see, the effect of subtracting 2, x minus 2, actually has the effect of shifting the graph 2 units to the right. 2 units to the right. All right, so understand that? It's important to see that. Okay? So this red graph would be the graph of g of x, which is x minus 2 squared. So let me go ahead and draw that. Try and put this in red, although it's going to be a thick point. We'll do the best we can. Well, it's not that bad. So it looks like this. So that effect of shifting it 2 units to the right. Okay, so this is the function here, f of x, g of x, which is x minus 2 squared. Okay? All right. Now, the notation would look like this. So g of x would be f of x minus 2. That's what that means. All right, so f of x minus 2 says I take f of x and I shift it to the right 2 units. So let's talk about that notation right here, this notation. So that's going to be important, this notation. Okay, so horizontal shift. Given a function f of x, and if you have a new function g of x, which is f of x minus h, which is what we talked about here, where this is g of x is f of x minus 2. So I take the function f of x and I shift it to the right 2 units. So it's counterintuitive of what you would think. Okay? So it says this, f of x minus h. See that x minus h, right? So 2 would be your h here. Is that clear? 2 is the h. X minus. See, it's this notation. F of x minus h. So x minus h. H is 2, a positive 2. So if h is positive, the graph shifts to the right. So that's why we shifted to the right 2 units. Okay? If h is negative, we would shift to the left. Okay? So let's look at an example again. Okay, so number 1, describe the transformation of the graph of y equal f of x minus 3. So remember when we looked at it, the subtract 3, the original input, you're decreasing that input by 3, but remember what effect that has. So if you think about this notation here, f of x minus h, when you think of that, remember a g of x, same thing as y, so I just have this as y. So when you think of that notation, f of x minus h, notice that when I rewrite it, I can write this as f of x minus 3, where h is this 3 right here. So h is positive, right? So h equals 3, which is positive, positive 3. So the effect is this. So the effect is we would shift, so the answer, we would shift f of x to the right 3 units. So that's what that does. It shifts to the right 3 units. So it's important you think of this notation right here, f of x minus h. All right, so let's look at this example. Number 2, describe the transformation. Describe the transformation of the graph of y equal f of x plus 5. That's a plus 5 right here. F of x plus 5. So you see where that 5 is on the inside? On the inside? So if it's on the inside, that's a horizontal transformation. Okay, now you got to be careful. Some students have difficulty with that. So they see that plus 5 and they want to think, well, I'm going to shift it to the right 5 units. I'm going to shift f of x to the right 5 units. But remember when we talked about, I tried to do the best I could with this idea here. Remember what happened, although we decreased the input by 2, so 0 subtract 2, negative 2, the effect is that the effect is you're actually moving the graph here 2 units to the right to get that same y value. Okay, because remember the y values stay the same, so it's the x values that change. So to get that same output, we needed to change the x coordinates 2 units to the right. Okay, so you have to think of this in terms of that notation that we just used. So you got to think about f of x minus h. So I want you to see this. I can rewrite this as y equal f of x minus a negative 5, right? X plus 5 is the same as f of x minus a negative 5. And so now their h is this negative 5. All right, so notice since h equals negative 5, which is negative, right? Negative 5, that's going to have the effect of shifting f of x to the left 5 units. So since h is negative 5, f of x is shifted to the left 5 units. Okay? All right, so that's number 2. Let's look at number 3. All right, let's suppose we had this one. Describe the transformation, or I should put this in S, plural, transformation or transformations of the graph of g of x, which is f of x plus 2 minus 6. So I want you to notice there are 2 transformations occurring. You have a number on the inside and you have a number on the outside. The outside is always easiest. That's always that vertical shift. And it's intuitively what you see. I'm shifted down 6 units. And then you have the number on the inside, which is a horizontal shift, which is not as intuitive. So you got to be careful with the non-intuitive part. But notice always go, when it's written like this, always go from left to right. So we're going to do the horizontal shift first, and you're going to do the vertical shift last. In a little while, in another lesson, you're going to talk about stretching and shrinking. You always want to do, when you have stretching or shrinking, when there's a number on the outside, you always want to do that before you do the vertical shifting. All right, so that's why it's always easiest to go from left to right. So when I go from left to right, I'm taking the function f and I'm shifting it to the, what is it? What do you think? 2 units to the right or 2 units to the left? It is 2 units to the left. Very good. Because I can rewrite this, as g of x, which is equal to f of x minus a negative 2 minus 6. So this is your h and this is your k. All right. And so in this case, in this case, I have two transformations, a horizontal transformation and a vertical transformation. So we're going to say shift f of x to the left 2 units and then down 6 units. Okay? And that's all that is. It's a very simple process. Okay? All right. One more. Describe the transformation or transformations of the graph of this of fh of x. So I need to do what to f of x to get this h of x, which is this. So I always go from left to right. Notice there are two transformations, right? There's a horizontal and there's a vertical. Horizontal, vertical. Now, be careful, counterintuitive here with the horizontal. So don't say you're going to shift it 4 units to the left because you see that negative here, right? Don't think like that. You got to remember our notation. So you're going to rewrite like this. Just say I'm going to rewrite this over. Oops, that's 4. And then plus 2. So you're going to say this is your h because x minus h. Remember, f of x minus h plus k. That's a k here. F minus x plus k. So f of x minus h plus k. So where this is h, which is the horizontal shift, horizontal, and k is your vertical. Okay? All right, so h is a positive 4, right? H is a positive 4. And then k is a positive 2. I'm going to put positive 4 here. Positive 2, positive 4. And so since h is a positive 4, since h equals 4 and k equals 2, we will shift f of x to the right 4 units and then up 2 units. Okay? So it's a very simple process. Just remember this right here. So y equals f of x minus h plus k. So horizontal shift. If h is positive, move right h units, right? If h is negative, move left h units. Okay? K, that's your vertical shift. K. So let me kind of do this way. So h would be your horizontal shift, k would be your vertical shift. Vertical shift, if k is positive, move up k units. If k is negative, move down k units. Okay, so it's not a difficult process, but that is our lesson on graphing functions using vertical and horizontal shifts.